Now let us do a problem. A 1000 kg car rounds a curve on a flat road of radius 50 meters at a speed of 15 meters per second. Will the car follow the curve or will it skid? This is the question. The data given is, assume there are two parts for this question. First part is, assume the pavement is dry and the coefficient of static friction is 0.6. Second bit, the pavement is icy and the coefficient of static friction is 0.25. Now we have to do the problem. Let us write the data. Okay. Here mass of the car is given as 1000 kilograms. And then the radius of the road is given as 50 meters. And then speed is given as 15 meters per second. Okay. And he is asking us whether the car follow the curve. That means this question is based on the uniform circular motion. Okay. Here, the centripetal force is equal to MAC, and then AC is the V square over R, where AC is the centripetal acceleration. Centripetal acceleration is equal to V square over R. Now, where comes the force to negotiate the curve? You know that to negotiate a curve, a force is required. That is nothing but your centripetal force. Here, where is the force? What kind of force is there to negotiate the curve? Here, let us consider this be the curved road, okay, on which the car is traveling. Now the center is somewhere here, okay, and then the car has to negotiate the curve. Now the friction acts as the centripetal force. Your centripetal force is not a new force. At times friction, at times gravitational force, okay, at times the tension acts as the centripetal force. Any force for whatever you have studied in your school, friction, gravitation, tension, any of these forces can act as the centripetal force. Okay, here in this case, the friction acts as the centripetal force. Now, first, let us calculate how much of centripetal force is required for the vehicle to negotiate a curve. Okay, here, this is the Fg acting vertically downwards, and this is the Fn acting vertically upwards, and here is the Fc. Here Fc is the friction. Fc is equal to F friction. Okay. Now first with the given data, we will calculate the Fc. Fc is equal to mv square over r. That we will calculate. So here this is 1000. And then velocity is 15 meters per second. So that is square. And then radius is 50 meters. So what is the centripetal force required for the car to negotiate? 4,500 newtons. This much of force is required to keep the car on a circular path. Otherwise, the car cannot negotiate a circle. Okay. Now, let us see whether in the first bit, A bit, let us see the A bit. In the A bit, whether the friction can provide the required centripetal force or not, we will study. So, I told you Fc is equal to F friction here. So, F friction is equal to mu Fn, you know. Okay. Therefore, here what we do is we will calculate. So, Fn is nothing but your mg. Fn is equal to Fg is equal to mg. Okay, because you are seeing, in the y direction, sigma Fy is equal to Fn minus Fg is equal to ma. And then here the object is, the car is not traveling along the y direction. Therefore, a is equal to 0. Therefore, Fn is equal to Fg. Your Fg is nothing but mg. Okay. Therefore, F friction is equal to mu mg. Now here in the first case, what is the value? 0.60 times 1000 times 9.8. G is 9.8. So what is the value? F friction value 5880 newtons. Okay, so FC is equal to here, in this case, 5880 newtons. Okay, so therefore this is greater than 5880 is greater than 4500. Therefore, here the car will negotiate a curve. No problem at all. Now let us see the second case. What is the second case? In the second case, the mu value is equal to 0.25. So let us calculate the friction. If friction is equal to 0.25 times 1000 is the mass of the object times 9.8 will give you the value 2450 newtons. 2450 newtons is less than 4500 newtons. Therefore, the car will not negotiate a curve. So it fails to negotiate a curve on an icy road. Now, what we have to do is, why it is happening? What is the physics behind this negotiating the curve? No, you have studied the Newton's first law, wherein there are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. So to change the direction of an object, you have to supply the force. Unless there is an external force or net force acting on an object, the object cannot negotiate a curve or can't change the direction. Here, the curved path means the vehicle or the car is changing the direction at every point. Okay, that is the thing. Here, the frictional force is providing the required centripetal force. Centripetal force is nothing but the force which is directed towards the center. Here, the friction is directed towards the center. So that is providing the required force to negotiate the curve for the car. Here, what is happening on an icy road? The vehicles, in general, what happens, I will tell you the actual story of this one. Suppose if this is the car and these are the tires, and then these are on the road. Okay, the car is traveling on the road. And then, okay, suppose if this is your vehicle. Okay, and then at every instant, whenever the car is the tires are rolling, here the tires are rolling. At every moment, when the tire touches the road, whenever some part of the other of the tire touches the road, whenever it is touching the road, this point comes to rest, momentarily rest. So when it is coming momentarily to rest means here the static friction comes into picture. Friction static. Okay, static friction comes into picture. Mu s, that means coefficient of static friction is always greater than coefficient of kinetic friction. When the car is rolling, the tires are rolling, as long as the vehicle is traveling on a rough path, the friction will be there, and then that friction provides the required centripetal force. Here, the tires are rolling. When the tires are rolling, the part of the tire which touches the road momentarily comes to rest. That means instantaneously the tire comes to rest. That means the static friction comes into picture. Coefficient of static friction is greater than coefficient of kinetic friction. That provides the required centripetal force to negotiate a curve. So no problem at all. The car can easily takes the curved path, and then it will safely travel. Suppose if the road is icy or if the road is slippery, then what happens? Instead of rolling, the tires will skid. Okay, when the tires are skidding, they are not coming to rest. Okay, the tires are not, if they are rolling, a part of the tire comes to rest. But when they are skidding, the tires will not come to rest, and the therefore the static friction will not come into picture. The kinetic friction comes into picture. As I already told you, the coefficient of kinetic friction is less than the coefficient of static friction. It fails to provide required centripetal force. Okay, so instead of negotiating the curve, the car flies off. Okay, now how to overcome this problem? Suppose if we remove the friction from the scene, then the car can easily negotiate. Now, by maintaining a specific speed, the car can easily negotiate the curve. So for that, what we do is we will slightly elevate the outer part of the road, okay, than the inner part. When we are elevating the outer part of the road than the inner part, then it becomes an inclined plane. Okay, just like this one, this becomes an inclined plane. When it is an inclined plane, it has some angle theta, angle of inclination theta. Okay, so when this is theta, here this is also theta. This object is your car, and then this is your Fn. Okay, this is your x-axis and this is your y-axis, and then from the geometry of the figure, as this is theta, this becomes Fn cos theta. Okay, and then this becomes Fn sin theta, and your Fn sin theta is the providing the required centripetal force. Okay, now let us write the equations. Sigma Fy is equal to Fn cos theta minus Fg is equal to Ma. And then the car is not traveling along the y direction, A is equal to 0. Therefore, Fn cos theta is equal to Fg. And then you know Fg is equal to mg. Therefore, Fn cos theta is equal to mg. Okay, let us consider this be the equation 1. Now we will write the x direction forces. What are the x direction forces? Sigma Fx is equal to Fn sin theta Fn sin theta is equal to your centripetal force. Okay, mv square over r. Okay, let this be the equation 2. Now what we do is we will divide the second equation with the first equation. Okay, 2 divided by 1. So Fn sin theta divided by Fn cos theta is equal to mv square over r divided by mg. Okay, Fn goes off and then mass goes off. You are left with tan theta. Tan theta is equal to v square over rg. Okay, now theta, we have to find out theta. Now, how much we have to raise the outer edge. So, for that we should know the theta. Therefore, theta is equal to tan inverse v square over rg. Okay. Now we will calculate for this case. Here the velocity is 15 meters per second. So 15 square divided by r is the 50 meters and then g is 9.8. This will equal to, this is equal to 0.4591. Okay, therefore theta is equal to tan inverse theta is equal to tan inverse 0.4591, that is equal to 24.66 degrees. Okay, so if you see this equation here, we eliminated the friction and also mass of the vehicle. Therefore, for all the vehicles, whatever may be the vehicle, it may be a heavy truck, it may be a light car, or it may be a cycle, whatever it may be. Okay, so whether the vehicle is light or heavy, the mass will not come into picture, only the velocity. As long as you maintain a specific speed, you can easily negotiate the curve, and then there is no question of flying of the vehicles and there is no question of accidents. Okay, so this is the beauty of the banking of the roads. This is what is called banking of the roads. That means we are raising the outer edge of the road. We are banking the outer edge of the road for the vehicles to safely negotiate the curve and then travel. Okay, that is the physics behind the curved paths are ghat roads. Ghat roads, if you check the ghat roads or any curved road, the outer edge is slightly elevated than the inner edge. Okay, this is all about the banking of the roads. Hope this helps. Thank you. Bye bye.